For decades, the global technology industry followed a relatively simple model when it came to processors. A small group of semiconductor companies designed the chips, and everyone else bought them. Intel dominated the world of PC processors. Companies like Qualcomm designed chips for smartphones. And for graphics and accelerated computing, NVIDIA built the GPUs that powered gaming systems and data centers. Technology companies focused on software, platforms, and services while relying on these chip makers for the hardware underneath. But in recent years, something significant has changed. Some of the largest tech companies in America, including Apple, Google, Amazon, Microsoft, and Meta, are now designing their own processors. This shift represents one of the biggest structural changes in the technology industry. To understand why American tech companies are designing their own processors, you have to start with control. Modern technology companies operate enormous computing infrastructures. Apple builds millions of devices every year. Amazon runs one of the world's largest cloud computing networks. Google powers massive search and AI systems. Microsoft operates huge data centers supporting cloud services and enterprise software. All of these operations depend on chips. And when your entire business depends on chips, relying entirely on third-party suppliers creates limitations. Designing your own processors gives companies control over the most fundamental layer of their technology stack. Instead of adapting software to generic hardware designed for many different customers, companies can design chips specifically optimized for their own products and services. Apple is perhaps the most famous example of this strategy. For years, Apple relied on Intel processors in its Mac computers. But in 2020, the company made a major shift by introducing its own line of processors known as Apple Silicon. These chips, including the M-series processors, were designed specifically for Apple's hardware and software ecosystem. Because Apple controls the operating system, the hardware design, and the processor architecture, it can optimize every layer of the device. This integration allows Apple to improve performance, battery life, and efficiency in ways that would be difficult using off-the-shelf chips. The results were dramatic. Apple's processors quickly delivered performance levels that rivaled or exceeded many traditional PC chips while using far less power. But Apple is far from the only company pursuing this strategy. Cloud computing companies are also designing their own processors. Amazon, for example, operates Amazon Web Services, one of the largest cloud platforms in the world. Its data centers contain millions of servers running a wide variety of workloads. Using standard processors for all those tasks can be inefficient. So Amazon began designing custom chips tailored to specific types of computing tasks. The company developed its Graviton processors for general cloud computing, and specialized chips like Trainium and Inferentia, designed specifically for artificial intelligence workloads. By designing these processors in-house, Amazon can optimize them for the exact needs of its cloud services. This reduces costs, improves performance, and gives Amazon greater control over its infrastructure. Google has taken a similar approach with its tensor processing units, or TPUs. These chips were designed specifically for machine learning. Training and running AI models requires massive amounts of computation, and traditional processors are not always optimized for those tasks. Google's TPUs accelerate machine learning operations and power many of the company's AI services. They also play a major role in Google's cloud offerings, where customers can rent access to these specialized processors. Meta and Microsoft are also exploring custom chip designs for artificial intelligence and data center workloads. The reason so many companies are investing in custom silicon comes down to scale. When a company operates millions of devices or servers, even small improvements in chip efficiency can produce enormous financial benefits. A processor that reduces power consumption slightly across a massive data center can save millions of dollars in electricity costs every year. Performance improvements also allow companies to deliver faster services, process more data, and support more users without expanding infrastructure as quickly. Another important reason behind this trend is supply chain strategy. Recent semiconductor shortages revealed how vulnerable technology companies can be when they rely entirely on external suppliers. If chip production slows or supply becomes constrained, entire product lines can be affected. By designing their own processors, companies gain more control over manufacturing relationships and supply planning. Although most companies still rely on external manufacturers like TSMC to produce the chips, owning the design allows them to control key aspects of the process. There is also a competitive advantage involved. When multiple companies use the same standard processors, their hardware capabilities tend to converge. Custom processors allow companies to differentiate their products. Apple's processors, for example, allow its devices to run certain tasks faster or more efficiently than competing devices. Cloud providers can offer specialized computing instances optimized for particular workloads. AI companies can build processors designed specifically for training and running machine learning models. This differentiation becomes increasingly important as computing workloads become more specialized. Artificial intelligence, video processing, augmented reality, and high-performance computing all benefit from hardware optimized for specific tasks. General-purpose processors can handle many workloads reasonably well, but specialized processors can handle specific workloads far more efficiently. Another factor driving this shift is the rising importance of artificial intelligence. AI workloads are pushing traditional computing architectures to their limits. Training large AI models requires enormous processing power, massive memory bandwidth, and highly efficient data movement between processors. Many companies believe the best way to achieve this performance is by designing chips specifically for AI workloads. Custom processors allow companies to tailor the architecture directly to the mathematical operations used in machine learning. This can dramatically improve performance and efficiency compared to general-purpose chips. The rise of custom silicon also reflects a broader trend in technology. The biggest tech companies are increasingly controlling more layers of their technology stacks. Instead of relying on external providers for critical components, they are integrating hardware, software, and services more tightly. This vertical integration can lead to better performance, greater efficiency, and stronger competitive advantages. But it also requires enormous resources. Designing advanced processors is extremely expensive and technically complex. Only companies with massive engineering teams and large financial resources can realistically compete in this space. That's why this shift is being led primarily by the largest technology companies in the world. Ultimately, the reason American tech companies are designing their own processors comes down to one fundamental idea. Computing power has become the foundation of the digital economy. The companies that control that computing power, from the software all the way down to the silicon, gain enormous strategic advantages. And in a world increasingly driven by artificial intelligence, cloud computing, and advanced digital services, the race to control the chips inside the machines may be just as important as the software running on them.